That's when everybody was like, he makes sure that was fun though. He didn't go bust, but that was easy.
That's why she shake her head because it's not really easy to kind of. I don't know exactly, but it's like it's out of your head.
Actually, then I was so not
Oh, I don't know.
Okay, if you guys can turn to page 20.
I mean, it's autoimmune. It's really hard to reverse. What she did is like very. She might have reversed it.
Okay, let me talk about the plan for this week. So we started ellipse day 3. We're gonna do a little bit more practicing, just trying to get using characteristics to get it down to the standard form. And then we're gonna start hyperbolas today. So hopefully we can get through a large portion of what I would like for us to get ahead with the hyperbolas. And then tomorrow we'll do day 2 of hyperbolas. Wednesday we'll do quiz review. Now Thursday, Friday, we're gonna let those 2 days be quiz days, depending on which day you want to take it. So if you want to take it Thursday, then we'll use Thursday to take it. For those of you who opt to take it Friday, you will just use that class period to study and review and study for Friday's test. So Friday's quiz. So you have an option either if you're not gonna be here Friday, you can take it Thursday, and then, or you can use Thursday as review day, and then Friday to take it. Okay, but either way, I'm only going to spend class time Wednesday to review, and Thursday, Friday will be testing environment. Okay. I'll still try to, I'll still hold review Thursday and Friday during 4th period. So if you want to come by, you can always come by either Thursday or Friday and do a help session. I will put together another quiz review. Okay, so any questions there? All right, so let's look at page 20. Let's finish problem number 2. We started this, right? Okay, so I changed the problem a little bit here so that it'll be a little bit easier to find those order pairs. Our A value is 7, our B value is 345, our C value is 2. The difference here is that we were given the A and C value, and we had to kind of work backwards to figure out the B value. Okay, so now that we have our A, B, and C value, we can go ahead and graph. Okay, we know it's going to be along the horizontal. So we know we're going to be targeting this formula here. Right, our focus is going to be horizontal from each other. Our A value is 7. see. B value is root 45, so we know it's a little bit under 7 here. Okay, standard form. Okay, we have our center. Our center is at -2, 2. Covertices, we know that covertices we're going to be moving up and down from the center, so we can just take that B value and attach it to that Y value of the center. Eccentricity is C over A. Okay. All right, let's do number 1 and 2 below just to get some additional practice, and then we'll move on to the next section. Okay, the length of the semi-major axis is twice the length of the horizontal semi-minor axis, and the length and the center is at the origin, and the B value is 3. Okay, so center is at the origin. Our B value is 3. So the length of the semi-major axis is twice the length of the horizontal semi-minor axis. So if B is 3, then what else can we figure out? A is 6, okay. It says a horizontal semi-minor axis, so we know that our B value is going to be moving left and right. A value is going to be the one moving up and down. And then your C value is always moving in the same direction as A, so okay, standard form. We know that this is along the vertical. We know that our A value is going to be underneath the Y value, right? And the B is going to be under the X. So we know that our formula will look more like this. Okay, we have everything plotted. We can go ahead and find our vertices and our covertices. Okay, so root 27 is a little bit more than 5. Okay, so we take the center and we make it move up or down by the y value, either root 27 or root 3. C over A. All right, let's try number 2. All right, focus, -1, 1, and -1, -5. Okay, if the focus is above each other, we know that so is our A value, and our B is going to be the one that's going to be horizontal, right? A and C will always be moving in the same direction. All right, so we know it's going to be more like this, right? Okay, how can we find the center? Yeah, between the two foci, right? Between the two focus points. We can count from center to focus to get the C value. Semi-major axis has a length of 6. What is that referring to? Mm-hmm. So 6 is the value of A, yeah. B value we can find using our formula. Okay, root 27 again, this time's for the B value. Any questions here? Yeah.
Why is there only one co-vertical? Cool. Co-vertical.
I think it's 2. It's just -1 plus or minus root 27. So we didn't put the exact points there because it's a radical. So I just had it. I know I'm moving left and right, so the plus or minus root 27 allows that for 2 points. Similar to what we do with focus if it's a radical. Okay, let's look at hyperbolas here. So turn to page 22. So hyperbolas, it's almost like if you were to cut a ellipse in half, and then you're making them turn outwards. So if you were to take an ellipse and you kind of fold it outside, this is what a hyperbola looks like. It's going to be so imagine you have 2 sides of an ellipse, you slice it down and you flip them both outwards. So hyperbolas will either open to the left. You can also think of it as kind of like a mirror image of a parabola opening to the side, or like this. So they always come in pairs. Hyperbolas always come in pairs. But even though this diagram is not a whole lot, a lot of the things that are associated with it is going to cause this to look a little messy, because we're going to have these asymptotes and boxes to kind of help us provide some boundaries so we know how wide and how long to make these curves. Okay, but ultimately the big picture is that your hyperbola is just these shapes. Okay, it's like a mirror image of a parabola facing away from each other. So let's start off with this here. Let's say we have a center. Now the center is not going to be part of the diagram. The center is going to be between the 2 arcs. Okay. And the distance from the center to the point on the arc is called the vertex. But now instead of it being an ellipse, now it's going to be vertex of these kind of mirror parabolas that are facing away from each other. Now we're going to also have these A and B values, but a lot of these are not part of the diagram because a lot of them are just used to help shape the graph. So I want you to kind of create a little box here. And the box is going to be where we're going to find a lot of information here. The distance from the center to the vertex is the A value. Distance from the center to the co-vertex is your B value. We also have a focus, but the focus is going to be outside the hyperbola. Okay. Again, we're using these dotted lines to indicate that these are not really part of the diagram, but they will help form the shape of our graph a lot easier. So now what you're going to do is you're going to connect from corner to corner, and you're going to be creating these diagonal asymptotes. And these diagonal asymptotes will kind of help shape your arcs. Right, we'll talk about in detail how to create the box and the dotted line. But as of now, if you have this in front of you, it's helpful because now you know how wide to make these arcs. You basically are going to kind of hug along the boundaries of your asymptotes. So here's one arc. Here's the second arc. Okay. The smaller and more narrow the box, the more inward your asymptotes will be, and then the less wide your hyperbolas will end up being. There's two more definitions here that's not part of the diagram. You guys can put this down here. There's the transverse axis. Transverse axis will connect the two vertices. And then you have the conjugate axis. And that's going to connect, that's the axis that connects the covertices. So in this example, from vertex to vertex, we have a horizontal transverse axis. And then we have a vertical conjugate axis because the conjugate axis will connect from covertex to covertex. Okay, let me draw the other scenario. Yeah.
Could all four all the corners be the CD? Or not
The covertices?
Yeah.
Uh,
Or would it just be the top two?
yeah, the covertices will be above each other, and then vertices will be across from each other.
And what are like the diagonals?
The diagonal points, these are the asymptotes, which we're always going to connect these asymptotes from corner to corner.
Okay.
It's going to create a big X. And that's going to tell us how wide to make these hyperbolas. Okay, the other scenario, type is where you have your arcs above each other, okay, rather than side to side. So again, let me put the center in the middle. Now the vertices will be above each other, and the co-vertices will be across diagonal, horizontal. Okay, just create a box here. Once you have the box, which will come from your A and B value, you're going to connect from diagonal to diagonal. And then you're just going to create your arcs, kind of let it hug along your asymptotes, and then through your vertex. And the focus is going to be outside the diagram. So in this case, we have a vertical transverse axis. Let's talk about the equations here. For a horizontal transverse axis, notice that this formula looks kind of like ellipse, but what's one big distinction that you see? Yeah. Ellipse has a positive separating the x's and y's. Transverse has a minus sign. Okay. Here, the a and b value, one does not have to be larger than the other, meaning that ellipse, your a value is always larger than your b value. And depending on whether it's above or below the x, is going to tell you which shape you're dealing with, okay, which orientation you're dealing with. With hyperbolas, your a is always going to come first, okay? Your a is always going to come first. So whatever is first is your a value. With ellipse, you have to compare the size to see which one is the a and which one is the b. But hyperbolas, whatever's first is your a value, okay? And if your a value is, if your x is first, then you know it's going to be a horizontal transverse axis. But if your y is positive in first, then you're dealing with a vertical transverse axis. So the big distinction here is for ellipse, x is always first, y is always second, but your a and b can flip-flop. For hyperbolas, your x's and y's can flip-flop, but your a and b will always be locked in. Your a is always first and your b is always second. All right, let's just go ahead and jump directly into an example, and we kind of fill in the gaps as we go through the example. Okay, so let's look at example 1. Graph the hyperbola, state the center, vertices, foci, thank you, eccentricity, and asymptote. Okay, so just by looking at this, we know it's a hyperbola because minus sign. Right, it looks a lot like ellipse, but it's just that minus sign is kind of giving it away. Okay. With hyperbolas, the a does not have to be larger than the b value, but you know what the a value is because it's the first one. So your a is 4 and your b is 3. Okay. Again, the a value is first, but it does not have to be larger. Notice that x is first as well, okay? Because x is first, you know it's going to be a horizontal transverse axis. You know your hyperbola will look like this. It'll be opening away from each other to the side. Okay, we find center the same way as ellipses. What's the center? -1, 1. Okay. You know you're going to move 4 units to the left and to the right. You're going to move 3 units up and down. Left and right, 4 units. Mark as your V. Up and down 3. Now, using your vertices and co-vertices, go ahead and draw a box, but just make it a dotted line because it's not really part of the diagram, but it will help provide us with some boundaries. Okay, everybody good with that? You're just taking those 4 points and you're just creating a rectangular box out of those 4 points. Let's go ahead and get the easy stuff out of the way. We can plot our vertices, and looks like it's not asking us for co-vertices, so just plot our vertices. Okay. Create a line from diagonal to diagonal and extend it beyond the box. Okay, everybody good so far? Now put your pen or pencil on the vertex, and you're going to make your kind of sideways parabola open up near the 2 asymptotes. You're going to make it kind of hug along that graph. So it's going to go along it, but it's going to get closer to it as well. Does that make sense? You're just kind of making it kind of move out towards those dotted lines. Make sure you try to make your graph as parabolic shape as possible. Make it curved, but then, you know, once it gets near that line, it's not going to move away from it. It's like a magnet. It's going to kind of keep drawing the arcs closer and closer towards those dotted lines. Okay, eccentricity is still the same, C over A, but we haven't found our C value yet, right? Okay, so we have a slightly different formula involving A, B, and C. Now it's going to be Pythagorean Theorem. It's going to be C squared equals A squared plus B squared, not C squared equals A squared minus B squared. Okay. So we're going to use that to help us find our focus. C squared equals 25. Square root of 25 is 5. So your C value will always follow your A value. You moved your A value left and right, so you're also going to move your C value left and right. But now your C value is going to be further out. Okay, it's going to be outside of your boundaries here. Okay, it's a nice whole number. We don't have to use plus or minus square root. We can just write down those order pairs. C over A. So 5 over 4.
Oh, yeah.
Now, your asymptotes, we also are going to create an equation for these diagonal lines that we create, okay? So it's always going to be y minus k and x minus h. Okay, I'll talk about this part in between, but let's do the easy part first. It's just y minus k, which is 1, is equal to, and then parentheses x plus 1. So it's kind of like how you were doing things with parabolas. Right, the k goes with the y, the h goes with the x. Now, what goes in here is slope. So don't think in terms of whether it's a over b or b over a. Just think in terms of slope. Count from the center to the upper corner of your box, okay, and do rise over run. Okay, rise over run. That's my slope. What's my rise? 3. What's my run? 4. 3 over 4. So just do plus or minus 3 over 4, and that's going to handle both of these diagonal lines. So you include the center and don't worry about whether it's A over B or B over A. Just count from the center and do rise over run. Whatever that rise over run is, that's going to be your slope. Yeah.
How did you figure out that it was going that way? Not with
Right. The way we know that is because whatever is first, whatever variable is first, is going to tell you which direction. So if X is first, it's going to open left and right. If Y is first, it's going to open up and down.
Okay, gotcha.
Yeah. So the thing we have to get used to with hyperbolas is a lot of, with ellipses, we're used to seeing the A value being larger. But here, number 2, you're going to see that the A is going to be the smaller value, which is okay. Okay, it's okay for the A to be smaller. It just means that your shape of your hyperbola will look a little bit, maybe a little bit wider, but it's okay to have the A value being smaller. Okay, it's just whatever's first. Okay, different. We have a different set of rules here. Okay, everybody okay with number 1? Okay, number 2. Again, we see that minus sign to give away that we're dealing with hyperbola. Now, we got to be careful here. What do you think the center is? Good. You start the X and you go with the Y. Okay, it's backwards, so you got to read that second term first. -5, 3. Okay, your A value is 2, and B is 5. Y is first, so you know it's going to be a vertical transverse axis. You know your hyperbola will look like this. It'll be up and down. Okay, let's go ahead and plot as much as we can here. Your A value is going to go up and down 2 units. Your B value is going to go left and right 5 units. Okay, go ahead and create a rectangular box that connects all 4 points. And then draw your diagonal line that will be your asymptote from corner to corner. Go ahead and sketch your hyperbola. It's going to be very wide here. So start on the vertex, and you're going to go out towards those dotted lines. Try to make your graph as parabola shaped as possible. Make it smooth and curved. Okay. Don't make it sharp. No sharp corners. And make sure that your graph is not going to bounce off of this and move back in. Okay, it's literally going to kind of bleed into that dotted line eventually, where we can't even tell anymore. So you're really going to make a graph kind of get closer and closer towards that asymptote as it moves out. Okay, let's find our vertices here. Okay, to find the focus, we have a slightly different formula like before. It was not a squared minus b squared, it's a squared plus b squared. And your c value will always move in the same direction as your a value. Okay, your a value went up and down, so your c value is also going to go up and down. Root 25 is 5, so root 29 is going to be between 5 and 6. You know root 6 is 36, so maybe like 5.5. From the center, go up. Again, your focus is going to be completely outside the diagram. You know how ellipses focus was inside your ellipse? Your focus now is going to be outside. Count from the center. Okay, eccentricity still C over A. Focus, you moved it up and down, so take your center and then attach that root 29 to your y value. Okay. Yes.
For verticals, it says to add k plus or minus a.
Mm-hmm.
Did you do? Oh wait, I got a and b wrong. That's why.
Okay. Yeah. So I know the formula says a over b or b over a. I would say don't worry about that. Just count from the center to the corner and just do rise over run. So I like to start off my line with just the easy stuff. Get the y minus k and the x minus h on one side. So I have y minus 3 equals, and I know that's going to be x plus h. Okay, I'll do my slope last. So to get the slope, start at the center and go to the corner of your box. Okay, so what will it take rise over run to get from my center to my corner?
5.
Okay, rise over run though. I got to rise how many units first? 2 over 5, yeah. If you always do rise over run, you never have to worry about, wait, is it A over B or B over A? Because you can just visually convince yourself that you're always moving up before you move to the left and right. Okay, so I don't want us to get thrown off by, wait, is it A over B or B over A? Because if you have the box in front of you, and if you know that you're starting at the center and you're moving to the upper corner, just count how many units you're going to rise before you count to the left and to the right. Okay, any questions? Okay, let's do more practice. This takes a little bit longer. It's a little bit more complicated. So let's see if we can, page 23. Let's just do 1 and 3. Okay, we'll do 1 and 3 on page 23. Okay. Anybody still need this page? Okay. All right, page 23. Okay, we're just going to do number 1 and 3. I'll work alongside you guys and see how you guys can kind of see how you do. Okay. Oh, another nice connection here is with your asymptotes, you're really just bringing that x minus 3 and y plus 2. You're just carrying that down, right? You're doing the y first and then the x, right? So pretty much everything by your asymptote is just going to carry down what you have in your parentheses, just without the squared. And then you just have to make an adjustment with your slope. Okay, let's practice here. What would the slope be?
2/6.
Wait, 6/2, right? Yeah, you're right. Rise over 1, so 6/2. Which you can reduce, or you can leave it at 6/2. I'm going to say plus or minus 3, but yeah, 3/1, you can say 6/2. If you don't reduce, that's fine. Yeah.
Can you go over how you were able to graph?
Both sides?
Yeah.
Yeah, so C is root 40. Root 40 is a little bit more than root 36. I know root 36 is 6, so I know it's like maybe 6.5, right? Okay. And your C is always going to move in the same direction as your A. Your A is moving left and right, so your C is always going to move left and right.
Thank you.
Okay, let's end with number 3. I'll leave this up here for another minute, and I'll show my work for number 3. Right, does anybody still need to look at number 1? Right, number 3, is it a horizontal transverse or a vertical transverse? Horizontal, because x is first, right? So whatever's first is what's most important. Right? That's going to tell you everything. So it'll tell you your A value, is going to tell you how it's going to open. And what is my slope? 3/4, right? 6/8. 6/8, rise over run. So you can reduce that 3/4, or 6/8 is fine as well. Plus or minus. I can leave the zeros out if I wanted to. I just figured that, put that 0 there to make everything kind of structured the same way. But you can drop the zeros, you can leave your 6/8 there. Okay, I'm gonna come around and check your page. Yeah, question.
For the asymptote, you have to do the -0, or can you just?
Yeah, you can leave the 0 out. You can say y equals plus or minus 3/4 x. Yeah, I just put it there just to have the same structure, but you don't have to. The only thing left to do is tomorrow we'll do complete the square. We'll do complete the square for hyperbolas, but from there we'll just start reviewing. Okay, we've covered everything by tomorrow. Wednesday review. Thursday you can take the test. Sorry, take the quiz, or you can sit quietly and study on your own. And then Friday, for those who want to take the quiz, can take it at that time as well. So Thursday, Fridays will be your quiz days.